Professor Rai, am I audible?
Yes,
Okay,
sir.
how are
Yes,
you?
sir.
How are you, Mr. Kumar?
Hello, sir. Good
How
evening.
are you? How are you?
I'm good, sir. How are you, sir?
Okay, you look very fresh.
Thank you so much, sir.
I mean, even after working for the whole day, you look really very fresh.
Thank you so much, sir.
And I don't know how you are becoming younger.
Thank you so much, sir. That is so kind of you, sir.
Okay. No. It is great to see that you are doing so well in industry, and so we'll hear from the industry person. That's a great advantage for us and for the faculty members and for the participants.
Thank you so much, sir.
Okay, for the good reception, I will keep my video off for a while, or no, just to at the beginning, just let us look at each other, and then I will keep it switched off. Can you see me?
Yes, yes. Nice to see you, sir,
Okay.
after such a long time.
Yeah, sure. Great, wonderful, absolutely wonderful. So, how is winter there?
It has started now.
Hmm.
A little chilly, I would say, in the evenings.
Acha. Not so cold.
Not so cold, but yeah, in the evening, it's good to have a
No, because
sweatshirt or something.
too cold to you is a Lucknow cold. So compared to that is nothing.
Nothing. That.
Yeah. Okay.
But sir, even I don't have any more experience to Lucknow weather because I have not been in Lucknow for such a
I
long
know, I
time.
know, I know, I know that. But once in a while you go, na?
Yes, yes.
Okay.
Sir, can I test my screen once?
Oh, sure.
I'm just sharing my screen. Just please let me
Okay.
know if it is
Okay.
visible. Sir, is it visible now?
Yeah, visible.
So is it showing the full screen or the
No.
presenter?
No. It is not showing the full screen.
Okay. Then I need to check how to make it a presenter view.
Okay.
Yeah. Let me just
Okay. No problem.
into it. Yeah. Just give me a second, sir.
Yeah, good evening.
I'm so sorry of this delay,
So
sir.
should I start? Okay, no problem.
Yeah. Yes. Yeah. So sorry, sir. This is some issue. I
Okay.
don't know why it's not happening. Yeah.
Okay,
Just give me 2 minutes, sir. Yeah.
okay, no problem.
Okay. Let me just do it then that way only. Should I start?
Okay.
Let it
No,
be.
let me introduce before. Yeah. Some of the introduction.
Okay.
So,
Okay.
okay.
Yes.
So myself, Dr. Pranav Kanti Rai, co-coordinator of the ATAL Faculty Development Program. I welcome you, all the participants, as well as our expert, Mr. Ashish Kumar.
Thank you
So
so
today topic is cyber physical system and industrial IoT. So let me give a brief profile of Mr. Ashish Kumar, who is a lead design engineer in Tata LXI Bangalore, specialized in EV thermal management and advanced computational fluid dynamics and finite element analysis and system reliability design. He leads the CFD team across the multiple plug-in hybrid electric program, focusing on board charger and DC converter, electric drive units, and battery thermal management. His work integrates digital twins, predictive modeling, and data-driven to deliver the production-ready solution. Now, regarding his academic background, Ashish earned a master's degree in power electronics from BIT Mesro and conducted doctoral research at IIT Kharagpur, centered on design of experiments and heat sink optimization and thermoelectric cooling prototype validated through simulation and lab testing. In industry, he has contributed to modular cooling strategies, improved heat dissipation and component reliability, and cost-aware thermal design that scale across the platform. He is currently working as a system engineer with Jaguar Land Rover on upcoming vehicle research and development. Across the academia industry, Ashish combines thermal engineering and power electronics to translate high fidelity model into durable manufacturable EV system consistently aligned with engineering best practices and program constraint. So this is the brief profile of Mr. Ashish Kumar. Now the session is yours. You may continue.
Sir, I think there was a problem.
Yeah. So,
Mr. Ashish Kumar has left accidentally. Yes, he rejoined now.
oh, rejoin.
Yes.
Okay.
Sir, you are muted, sir.
Yes. Is it fine now?
Yes, sir. It's fine.
Yeah. Now. Is it okay, Mr. Ashish Kumar? Now.
Yes,
So
sir.
you may continue. You may continue now.
Yeah, yes, sir. So let me know if my screen is visible.
Yes, sir, it's visible.
Is it visible in the presenter mode or is it in the normal mode?
So only one screen is showing.
Okay,
One design only.
it's fine, right?
Yes, sir.
Yeah, okay. All right then. I'll just start with my presentation. Yeah. So, good evening, everyone. My name is Ashish Kumar. I'm a lead design engineer at Tata Elxsi. Today we'll take a structured practical tour of how cyber physical systems and industrial IoT combine to enable Industry 4.0 in manufacturing. The objective is
Excuse
to
me,
give
sir.
you. Sorry.
Sir, sorry, sir. Sorry to interrupt, sir. But no PPT is showing.
PPT is not showing.
No, sir.
Okay. Let me share my screen again then. So sorry, sir. This is unexpected.
No.
Yeah. Sure. Okay, this is done. Is it visible now?
So it is loading.
Okay. Is it visible now?
No, sir. It's still showing it's loading.
Okay. This should not happen like this. Just give me a second. Huh?
Yes, sure.
I'm
Okay.
again trying. I'm
Okay,
again
okay.
trying.
Okay,
Yeah.
okay, no.
Okay, actually, okay, I understood. Actually, WebEx has not been given the authority to look at my screen. That is why it is happening.
Professor Kundu.
Yes, sir.
Professor, I mean, is there any permission or etc. required for Mr. Kumar?
No, sir. I have given him the permission, but it's in his system. His system has no access to the WebEx screen.
No, but a little while back we saw, no?
Sir.
Then how it is that his system has not this thing? Because a little while ago he was showing that PPT. Only thing that it was to be made full screen, this problem occurred.
Yes, sir. Now I think it should be okay.
Yes, I have again. Actually, I think in my system, WebEx was not given the permission to.
Is that okay? Now is it okay?
Yes, yes. Most
No.
probably it will work now.
Okay,
Just give me a
let's see.
second.
Let's see.
Is it visible now?
Sir.
Yeah,
It's
yeah,
not
screen is
visible.
coming.
Yeah. Okay. Okay.
Now this is fine. This is fine. Just this is
Yeah. So can you see my
Previously it was
screen?
fine, sir. Previously it was fine. It is not now full screen.
Now it is not full screen?
No, sir.
Okay.
It was fine previously.
previously it was full screen. Previously it was full screen.
Okay.
Yeah. Is it no? Huh?
Okay. It should happen in that way only, but it is not happening like that. Okay. Give me one more second. This WebEx is showing some errors. Anyway, I'll just use the normal screen now. Yes.
That would be okay.
Yeah. I'll just start from this
Yeah,
only.
yeah.
So first, like again, good evening, everyone. My name is Ashish Kumar, and I am a lead design engineer at Tata Elxsi. Today, we'll take a structured, practical tour of how cyber physical systems and IoT, industrial IoT, combine to enable industry 4.0 in manufacturing. The objective is to give a clear technical foundation showing real world patterns and case studies, and leave with an adoption roadmap and checklist we can use later. I'll move on progressively from definitions to architecture, technologies, benefit, risks, and practical examples. Okay, so this slide shows the session flow, and we'll start with context and definitions to ensure a common vocab. Next, we'll examine how they integrate in a layered architecture and how data flows through the system. The middle section focuses on enabling technologies, sensors, connectivity, edge cloud, AI, and the measurable benefits such as predictive maintenance and improved OEE or overall equipment effectiveness. We'll be using this word pretty often in the slide later. We'll cover risk and mitigation, then review case studies and future trends. I'll keep each section practical and example driven. Industry 4.0 describes the transformation of manufacturing through the integration of digital technologies with physical processes. At its core are real-time data flows, automation, and systems that adapt to changing conditions, unlike earlier automation waves that focused on isolated machines. And Industry 4.0 emphasizes connectivity across the plant and enterprise, which includes machines, sensors, humans, and business systems exchanging information. For technical terms, this means designing systems that are observable, controllable, and secure with clear interface between operational technology and information technology. So why Industry 4.0 matters? So Industry 4.0 delivers measurable business outcomes, faster responses, reduces lead times, and improve customer satisfaction. Higher quality comes from continuous monitoring and inline inspection that detect defects earlier. Lower operating costs arise from optimized energy usage, reduced downtime, and predictive maintenance. Additionally, Industry 4.0 enables new services like remote monitoring, outcome-based contracts, and product lifecycle analytics. For engineers, the key is to tie technology choices to business metrics like, again, OEE, MTBF, that is mean time between failure, and MTTR, which is mean time to repair, defect rate, and energy per unit. Industrial revolutions. So a quick historical view helps place Industry 4.0 in context. The first three revolutions introduced mechanization, mass production, and automation. Industry 4.0 builds on automation but adds tight integration between physical processes and digital systems. Software that models, controls, and optimizes physical assets in real time. This changes system design from isolated PLC programs to distributed data-driven architecture combining control loops, analytics, and human decision supports. So CPS, now coming to the definition and the core idea. So cyber physical system tightly coupled computation and physical processes. Sensor measure the physical world, computation makes design decisions, and actuator change the physical state, forming closed loops. CPS are characterized by real-time constraints and deterministic timing requirements. Control decisions must occur within defined deadlines to maintain stability and safety. Examples include motion control systems, process controllers, and safety interlocks. CPS design requires attention to timing budgets, jitters, and fail-safe behavior. We'll be using these terms often and we'll be describing these things later. So CPS differ from general IT systems because they must meet strict timing and reliability constraints. Real time means the system responds within a bounded time. Determinism means behavior in predictable under specified conditions. Safety is often paramount here, which means system must fail safely and provide diagnostics. These characteristics influence hardware sections, which are real-time controllers, RTOS, communication choices like real-time field buses, and testing strategies like SIL, which is hardware in loop, software in loop. When integrating CPS with IIoT, preserve these properties by isolating control loops from non-deterministic traffic and using gateways or edge devices for safe interfacing. CPS components and layers. a CPS is basically a built from sensors, controllers, actuators, and real-time networks. Sensors provide measurements, controllers run control algorithms, actuator execute commands, field networks like EtherCAT, Profinet, CAN provide deterministic communication. Each layer has constrained. Sensor must meet sampling and accuracy requirements. Controller must meet compute and timing budgets. Actuator must have required torque or flow. When designing a CPS, specify performance requirements for each component and validate them under operating conditions. So control loop performance depends on sampling rate, processing latency, and actuator responses. For example, a servo loop sampling at 1 kilohertz must complete sensing, computation, and actuation within 1 millisecond. If network latency or compute time increases, loop stability decreases. Jitter or the timing variation can cause oscillations. Engineer must allocate a timing budget and design for worst case delays. When integrating IIoT, avoid routing real-time control traffic through non-deterministic networks. Use local controllers or edge gateways to preserve timing. Many CPS operate in safety critical context. Functional safety standards like IEC 61508, ISO 13849 define safety integrity level and require systematic design, verification, and documentation. Redundancy like dual controllers, redundant sensors, voting logics, these improve availability and safety. Safety design includes diagnostic, safe states, and controlled shutdown procedures. Certification requires traceable requirement, design artifacts, and include safety engineers early and treat safety as a design constraint. Yeah. So now coming to this example, which is a CPS, which is a motion control system. A motion control system is basically a classic CPS example where the encoder measures the position, the controller computes corrective action through a PID controller or a model based. The motor driver applies torque. Key metrics include sampling rate, encoder resolution, control loop latency, and torque margin. Common failures mode include encoder misalignment, communication losses, and thermal overload. Mitigation are like we can mitigate it through watchdog timers, redundant sensing, thermal monitoring, and safe stop logic. This example highlights the multidisciplinary nature of CPS design. So yeah, so testing CPS requires simulation and hardware in loop. Testing to validate behavior under realistic conditions. Software in loop validates algorithms. HIL connects the controller to a simulated plant to test responses and fault handling. Regression testing ensures changes don't introduce regressions. Fault injection test how the system handles sensor failures or comms losses. Maintain traceability from requirement to test and record results for certification. Effective testing reduces field failures and shortens commissioning timing. So industrial IoT applies to IoT principles to industrial settings. IIoT systems collect telemetry from sensors and machines, aggregate, analyze it, and present insights to operators and systems. The emphasis is on operational visibility, analytics for maintenance and optimization, and integration with enterprise systems, which is an ERP, which can be an MES or an ERP. IIoT differs from consumer IoT in robustness, security, and industrial protocols. For technical teams, IIoT projects requires careful selection of sensors, gateways, and data platforms that meet industrial reliability and security expectations. The IIoT stack organizes responsibilities. Devices capture raw signal, gateways and edge node pre-processes these data, filter noises, and enforce local control policies. The cloud stores time series data, runs heavy analytics, and ML training, and host dashboards and APIs. Application integrate insights into, again, this ERP system for scheduling, quality, and supply chain decisions. Each layer has its own trade-offs. Edge reduces latency and bandwidth. Cloud provides scale and long-term analytics, and design decisions should be driven by use case requirements for latency, privacy, and compute. Yeah, so basically selecting sensors and actuators is foundational here. Vibration sensors are common for rotating equipment monitoring. Temperature and pressure sensors are essential for process control. Vision systems enable visual inspection. RFID supports traceability, like that. Key selection criteria includes measurement accuracy, sampling frequency, environmental rating, which is like a IP rating, ingress protection, and calibration intervals. Actuator must meet torque, speed, and duty cycle requirements. Consider maintaining maintenance, access, and replacement cost. Good sensor selection reduces false positives and improves analytics quality. Yeah, so connectivity choices depend on the use case. Wired industrial Ethernet provides deterministic performance for control logics. Wireless options add flexibility for mobile robots or retrofits. Private 5G offers low latency and high bandwidth for vision and augmented reality. LoRaWAN supports long range, low bandwidth telemetry. Consider interference, physical layout, and security, for instance. And for CPS integration, keep control traffic on the deterministic wired networks or local edge devices. Using wireless for monitoring and non-critical telemetry unless the wireless solution guaranteed required latency and reliability. So basically, we'll be focusing more on the wired connectivity rather than a wireless connectivity because of the low latency. So edge computing processes data close to the source to meet latency and reliability needs and to reduce the bandwidth. Using edge for real-time control, local anomaly detection, and pre-processing, and cloud is the ideal for historical analytics, model training, cross-site comparison, and dashboards. Many architectures use a hybrid approach where edge is used for immediate action, cloud is used for strategic analysis. Consider cost of data transfer, regulatory constraints on data residency, and the need for offline operation when designing the split. IIoT data flows through a life cycle, capturing the raw signal, pre-processing at the edge to remove noise and reduce volume, store time series data for trend analysis, run analytics and machine learning to detect anomalies or predict failures, and finally act, which is either automatically or via control system or by notifying operators and triggering maintenance workflows. Each stage requires policies for data quality, retention, and access control. Instrumentation and metadata like timestamps, device ID, and calibration data are critical for reliable analysis. Protocols enable devices and systems to communicate. OPC UA provides a rich semantic model and builds in security, making it a strong choice for the interoperability. MQTT is a lightweight and well suited for telemetry and cloud ingestion. Legacy protocols like Modbus and Profinet remains common on shop floors. Integration often requires gateways that translate between field protocols and higher level services. When designing an IIoT solution, choose protocols that meet latency, semantics, and security needs and plan for protocol translation when legacy equipment is present. So IIoT platform provides core services like time series databases, optimized for high frequency data, analytics engines, model hosting, and dashboards. Integration with MES, which is again coming back to this MES, which is a manufacturing execution system, and ERP systems enable analytics to drive scheduling, quality control, and supply chain actions. APIs and event stream allow other systems to consume insights. When selecting a platform, evaluating scalability, data retention policies, integration capability, and support for edge cloud hybrid deployments, and also considering multi-tenant and security feature for enterprise deployment. Analytics maturity moves from descriptive, that is what has happened, to predictive, that is what will happen, to prescriptive, that what to do. So predictive maintenance uses machine learning models trained on historical sensor data for forecasting failures. Prescriptive analysis recommend or automate corrective actions. Model life cycles management is critical. Models must be trained on representative data, validated, deployed, often to the edge, and monitored for drift. Establish processes for retaining and version control to maintain model accuracy and reliability. So coming to the digital twin, a digital twin is a virtual representation of a physical asset or process that is continuously updated with the live data. It enables simulation and what if analysis, testing changes in the virtual model before applying them physically. Twins support predictive maintenance by simulating degradation and can be used for operator training and process optimization. Building a useful twin requires accurate models, reliable data feeds, and synchronization mechanisms. Twins are powerful for complex assets when simulation reduces risk and cost. Edge AI runs interference close to the data source to meet latency and privacy requirement. Techniques like model compression and quantization reduces model size and compute needs. Edge AI is ideal for the vision inspection, local anomaly detection, and control decisions that must occur within milliseconds. Deploying models to edge devices requires a deployment pipeline, monitoring for model drift, and mechanism for secure updates. Edge AI complements cloud analytics by enabling immediate actions, while the cloud handles heavy training and cross-site learning. OT, which is an operational technology environment, benefit from DevOps and machine learning ops practice adapted for safety and reliability. Continuous integration and deployment pipelines automate testing and deployment of firmware and models. Versioning and rollback are essential to recover from the faulty updates. Stage rollouts and canary deployment reduces risk. Monitoring deployed artifacts for performance and drift ensures system remains reliable. So integrating change control and approval workflow to meet the safety and regulatory requirement. So now how CPS and IIoT work together is clearly shown by this Venn diagram where basically these CPS and IoT are complementary. CPS focuses on deterministic control and safety, while IIoT focuses on telemetry, analytics, and business integration. So when combined, IIoT provides data that informs CPS control strategies, like enabling closed loop optimization where analytics suggests set point changes or maintenance action that CPS executes. The integration must preserve CPS timing and safety properties while enabling data-driven improvements. Architecture typically use gateways and edge nodes to mediate between CPS and IIoT domains. A practical reference architecture separates responsibility across layers. Devices and PLCs handle real-time control. Gateways perform protocol translation, local analytics, and enforce safety boundaries. The cloud stores long-term data, runs heavy analytics and model training, and hosts dashboards and enterprise disintegration. Applications consume insights and drive drive business processes. Security, device management, and data governance span all layers. This architecture supports incremental adoption. Start with the device and integrate edge integration for a pilot, then extend cloud analytics and enterprise integration. So walk through a concrete data flow. A vibration sensor detects rising amplitude. The edge node filters and compute features. The cloud runs a predictive model and flags a likely bearing failure. The system triggers a maintenance ticket, and if configured, the CPS reduces machine speed to prevent damage. At each hop, consider latency, reliability, and security. So, for safety critical actions, ensure local control decisions remain within the CPS, use cloud recommendations, and scheduling and non-urgent adjustments. Integration can follow several patterns. Gateways translate legacy protocols to modern ones and provide buffering and security. Proxies forward data with minimal processing, which are useful for simple telemetry. Native integration is ideal when devices support modern protocols and security natively. Choosing pattern based on device capability, latency needs, and upgrade the cost. Gateways are common in brownfield deployments where replacing legacy equipment is impractical. So successful Industry 4.0 project requires collaboration across IT, OT, and data teams. OT, or the operational technology, owns control systems and safety. Information technology manages network, cloud, and enterprise integration. Data teams build analytics and models. Establishing a governance model that clarifies ownership, change control, and incident responses. Cross-functional team accelerates deployment and reduce the friction, including operations early to ensure solutions fit real workflows and maintenance practices. Analytics must lead to concrete actions also. So defining how alerts are generated, who receives them, and when actions follow, integrating with the maintenance system to create a tickets automatically. For automated actions, defining safe boundaries and human in the loop policies, using selection escalation path for critical events, operationalizing insights require clear SLAs and runbooks so operators know how to respond and trust the system. So this slide basically summarizes the core technologies we have discussed: sensors, actuators, which provides the raw signal, connectivity moves the data, edge and cloud provide compute and storage, and AI extract the insight. Digital twin enables simulation. Security and standards like protocol and data models are foundational. When planning projects, prioritizing technologies that directly address our use case and measurable KPIs. Industry 4.0 delivers tangible benefits. Efficiency gains come from optimized scheduling and reduced downtime. Quality improves through inline inspection and traceability. New services like predictive maintenance subscriptions create recurring revenues. Quantifying benefits with KPIs and pilot projects to build a business case. Using small high impact pilots and to demonstrate ROI before actual scaling. So predictive maintenance uses sensor data and machine learning to forecast failures. The pipeline includes data collection, feature engineering like vibration spectral features, and model training and deployment. Successful deployment reduces unplanned downtimes and maintenance cost. Measuring success with mean time between failures and mean time to repair improves the track cost avoidance. Starting with high value assets and building moderate iterations, validating predictions against actual failures. IIoT enables continuous quality monitoring and full product traceability. Vision system detect defects in line, process parameters are logged for each batch, RFID or barcode tracking provides genealogy. These capabilities speed root cause analysis and make recalls targeted and faster. For regulated industries, traceability support compliance is required and implement traceability with consistent identifiers and integrating with MES for end-to-end visibility. So IIoT helps measure and reduce energy consumptions by monitoring energy per unit and identifying inefficient equipments or idle periods. Analytics can optimize schedules to run energy intensive processes during off peak hours or balance the loads. These improvements support sustainability targets and can reduce overall costs. Tracking energy KPIs and integrating with corporate sustainable reporting can be done from here. Connectivity increases attack surface. Threats include unauthorized access, supply chain compromise, and ransomware. Practical control include network segmentation, like separating OT and IT traffic, strong identification and access management, secure boot and firmware signing, and continuous monitoring. Operational practices require regular patching, backups, and incident responses plans, which are very much essential. Security must be designed in and from the start and included in procurement and vendor contracts. Most factories have legacy equipment that lacks modern interface. Gateways translate protocols and provide buffering and security. Adopt standards like OPC UA to create semantic consistency across devices. A phased modernization approach, which is a pilot, retrofit, and then replace, reduces the risk and overall cost. Maintaining documentation of mapping and transformation are required to ensure high data integrity. Scaling IIoT requires device lifecycle management, provisioning, firmware updates, and decommissioning. Fleet management tools automate updates and monitoring. Multi-site deployments need orchestration and consistent policies. Planning for growth in bandwidth and storage as telemetry increases. Using cloud and edge capacity planning to avoid bottlenecks and ensure predictable performance. Technology alone won't deliver this. People and processes matter here. Creating cross-functional team and a center of excellence to capture the best practices is required. Investing in training for OT staff on data tools and for IT staff on industrial constraints. Establishing governance for data access, change control, and KPIs, and clear roles and responsibilities reduces friction and accelerate adoption. To close, CPS and IIoT together enable smarter, more efficient manufacturing when implemented with attention to control properties, data quality, and security. Starting with an assignment and a focused pilot that targets a measurable KPI, and if the pilot succeeds, scale with standards, governance, and a center of excellence. Immediate next steps would be inventory assets and protocols, selecting a high value pilot, defining KPIs and data requirements, and assemble a cross-functional pilot teams. Yeah, thank you so much.
So
Um, Mr. Kumar,
Yes.
actually, it's a wonderful presentation. Beautiful. I mean, it was very lucidly explained. The interactions between IoT and CPS. Um, now, I mean, I was a bit curious to know as to how in automotive applications, say for example, this can be used, giving a real life development case.
Mm-hmm.
Can we have some example, like say in any real life development case?
So I would like to quote a very recent example. Currently, I'm the part of Jaguar Land Rover, and we are developing a new vehicle for our 2028 series.
Oh, that's
So
great. That's great. Yeah, wonderful. Congratulations. Wonderful. Okay.
thank you so much, sir. So basically, it's a
But
Jaguar
it is
series.
headquartered in UK, right?
Yes, sir. It's in
Yeah.
Gaydon.
Yeah.
Gaydon. Yeah. So yeah, I've been associated with JLR for almost 2 years now. I've been working on from the power electronic side as well. So I was working on the DC-DC board and the onboard charger. But now I'm working in the capacity of a system engineering for a system engineer for the EDU, which is the electric drive unit, which includes the inverter, motor, and the transmission.
Can we hear something about that? Because that is a very interesting area.
Okay, yeah. So, so coming to the question that you asked. So here, there is a lot of so basically, if I want to tell you about the IIoT and the CPS, you must have got a very basic idea of understanding that we need to reduce the downtime. That is one thing. We need to also test new ideas and new ideas. For that, we need pilots. If at all the failure comes, I think this. Can I? Yeah. Hello.
Yeah.
Yeah. So, so, and the third thing is to identify the failure as soon as possible. So basically, here we are not shying away from getting a failure, but to identify, make it fail safe. So now coming to the implementation now, the part says that for each and every component here, especially if I'm talking about the EDU, I can see that for each and every component, we have developed our own HIL bench where we test it and we try to find out, and it actually requires a lot of sensors and actuators, and it basically senses in that sense that as soon as the error arises, it goes to the cloud, so that all the stakeholders in the project are able to understand and see, even it is coming from the actuator side, it is coming from the electrical side, or from the mechanical coupling side, everything is combined to a single point of source, where each and every stakeholder has the access to all the set of failures that a particular component has occurred, has gone through basically. So basically detection as well as implementing newer ideas is much more easier when we adopt this kind of a technology for our work. Earlier we used to have a lot of reporting happening for each and every component, but now everything is centralized, and the data through we also have an ERP system, by the way. So the data is passed to the cloud, and all the relevant stakeholders can have a look, and accordingly they can develop their own strategy for the subsequent component. Am I like did I answer your question?
Yeah, you're, it was audible. Whether Mr. Kumar?
Yes.
Yeah. So actually, it is a very interesting that you have explained regarding CPS and IoT, AI analytics, digital twin, all those things. Yeah. Now, what is how do you implement the digital twins or in industry but
Okay, so basically, if I want to tell you about the digital twin, it is basically a system. This is digital twin is something which we have been using for a very long time now. Digital twin is not a very recent technology, but a digital twin equipped with the other information databases is something which has been started now. I'll tell you one instance where, like, I remember that when we were even in college, I remember we have a D space devices which basically works as a digital twin. So basically, and if I want to give you a very basic idea, it will be a CFD analysis where we develop a actual, like, let's say we have a motor. So motor, we are going to first develop it in a CFD or in a CAD domain. We will develop it, and we will give specific properties so that when it is like which we do it actually that coming to a motor, when I want to develop a controller for this motor, what I'll do is I will develop a motor in the 3D system, in a like a digital system. Then I will provide this with the values of the duty cycle or the drive cycle that is going to, like I'm talking about this in perspective of EV. So we will provide the same drive cycle to it to understand what kind of performance, what kind of torque requirements, and what kind of acceleration I can get when I will be utilizing it in a specific terrain or I would say a geographic environment. So I'm assuming that when we are traveling on an uphill somewhere in the North India versus when we are driving in a plains like Delhi or somewhere like that. So the drive cycle changes, and as the motor performance also changes. So this by doing a virtual simulation of the same thing, we are reducing the cost and we are able to almost uh, realize the actual performance what a motor can deliver when it is going through a practical simulation, a practical environment.
Okay, okay. Thank you, thank you.
Yeah.
So from your CV, I could know that you are doing PhD in IIT Kharagpur. So what is the
Yes.
status of this one?
So basically, like I'm just awaiting my final viva voce now. The reviewer has already communicated the comments, and like because of owing to this a little difficult schedule, things were not able to match up properly.
So,
But
so both the Indian and foreign review has come.
yes, sir, it has came long
Okay,
back.
congratulations,
Congratulations,
congratulations.
congratulations.
This is
I
a
mean,
small part now that I was not
ac-
able to complete it because
no,
there
it's
was
okay, perfectly all right. I mean, it is not in your hands, but that both the comments have come, and so now very soon, I believe the your viva will be organized, right?
yes, most probably I am assuming that by this year itself it should happen
Great,
because
great, wonderful, wonderful, much awaited, long awaited thing. I mean, a special congratulations for that.
thank you so much.
Uh, and well, acha, by the way, coming back to this,
Yes.
this what Professor Roy asked is that
Mm-hmm.
in terms of the digital twin, my perspective is a bit slightly different, but the
Mm-hmm.
question area is same.
Yeah.
Is how, because you are from industry, so
Yeah.
that question perhaps would be useful for many who are actually from academics, because see
Okay.
when you approach the authority for funding for digital twin and all, maybe in
Yes.
your organization or elsewhere, as you have
Yes.
already got the experience, etc., for Jaguar and for LXC and also your client organizations. I mean,
Yes.
how someone approaches to that in terms of, say, investment, in terms of cultural readiness, in terms of I would say coming out of the comfort zones, and all these things, the cultural aspects. That is, so how these things you find are being addressed for a successful and smooth implementation.
So
I mean, these 2 3 aspects I have told. I mean, you may not remember all that, so just keep in mind that I've talked about cultural, I've talked about investment, that is economics, and I have talked about the other impediments, whatever the impediments you consider. Yeah, maybe beyond that also there are maybe few.
so like basically you wanted to understand like how the academicians like can help the industry.
No. My question is
Huh.
no. My question is that most of the participants are in academics.
Yes.
So,
Yes.
but since you have the exposure in in industry for quite some time
Yes.
now, I mean,
Yes.
when you approach that, okay, we would move on to this system from a legacy system or something. I mean, what
Okay.
are the courses that, because see, academicians will get that feel and perspective as to what happens in industry in real situation where the projects are approved, how the projects are approved, what the impediments, what the questions, how the feasibility, etc. are questioned, and all those things.
So, sir, so to answer you,
So forget about, sir, please forget about the academician part of it. You just say in simple, automatically it will benefit the academicians. Okay. So don't focus on the academicians. I just mentioned that many of them are academicians who perhaps didn't get an opportunity to go to industry so often. So how it is implemented in industry, if you can explain that, then there will be an idea for all of them who couldn't go so frequently to industry. Will have an idea how it is implemented or what is the impediment, how justifications are prepared.
okay, so sir, there are like
Mr. Kumar, are you clear about the question?
yes, I think
I tend to call you Dr. Kumar because it is only Bhai is left. And I know what kind of person you are, and it will be cakewalk for you. So so be that as it may, that the question, have you understood the question? Forget my mentioning about the academicians. I just mentioned as this thing that since there is an industry perspective, it will benefit. That's my point. But you go ahead to anybody, say for example, who are interested.
okay. So, sir, like if I want to give you an understanding of this thing, I can tell you it from both sides, because earlier I was working from the consulting side where we are working as
that is precisely was my question. That's precisely was my question. Yeah,
So,
tell us. That is very, very helpful.
Okay, so I have been fortunate enough that I have worked on the both sides of the table. So coming from the engineering consulting side from Tata Elxsi, and now working within original equipment manufacturer, which is JLR. So when we talk about, the scenarios are pretty opposite and contrasting, I would say, because in consulting, engineering consulting, what happens is that
JLR is the Jaguar.
yes, sir, Jaguar Land Rover.
Yeah.
So basically coming from the Tata Elxsi side or the engineering services side, where we work on the requirement of the customer. So if there is a willing customer, or if at all, if we have like from we have a team here in R&D who are working on developing newer and novel technologies which can be showcased. Even I myself is the part of one of the passport battery passport initiatives, which where we are using blockchain for developing this repository for the this battery. So here there are two things which are there. One is either the requirement from the customer, or a willing problem, like a life problem which we can find out. And the second thing is, if we are coming with our own solution, uh, like example, working on hydrogen IC engine, or like working on this blockchain development of this battery passport. These are the things that we can go and showcase. So in engineering services, we generally go white paper. These are basically research papers only, but only for specific for the industry. And these are published in company journals, as well as there are some private organizations as well who provide this kind of space for technical space for the engineers. And for the companies, of course, through which the willing companies can come up and check with them that how an arrangement can be done. While coming coming to the OEM side, so it is more of a research oriented work where we see and depending on the benchmarked data from other companies, or if we come up with some our innovative R&D, first we will try to develop a patent. So starting from ideation to a small prototype, a pilot project, and later going to the patent is how we approach when we go from the OEM side. But contrastingly, in engineering services side, it is more like on a requirement basis, I would say. Does that answer the question, sir?
Yeah, it is okay, Mr. Kumar.
Yeah.
Thank you for your presentation explanation. So
No, but I think the participants might ask some question. This session is up to 7:30, right?
Yeah,
yes,
we
sir.
have
Yes,
half
yes,
an
yes,
hour.
yes, yes, yes,
So,
yes, sir.
so participants might ask some questions. So, I mean, if the question, see, I would ask the participants. Sometimes they feel, what question do I ask? I mean, whether it would sound, because, but never mind, because we are people, we are also learning. So in the course of all these discussions, as I am asking a question, I too am learning something out of it, you know. So never feel that, okay, if I ask a question, how would it sound to the participants? Because participants, uh, I do not know here, might have a some people might have a propensity, okay, forget it, oh, we have listened, etc. But this is an opportunity to interact. So if you have any question, because I know he is extremely knowledgeable person, and he is very capable, talented person, kind of a thing. So and he will explain with all patience, I know. So please go ahead and ask some questions, whatever comes to your mind, whatever. Never think that it has to be a great question, that it will earn, the question will transform into a PhD thesis. No, nothing. Just simple questions. Because that is the purpose of this FDPs, that just not a one-way lecture. The purpose is to interact. That is why we are taking this opportunity to interact with, the speaker, etc. And I hope the same thing will be followed. Yeah. I mean, ladies and gentlemen,
yeah,
I would expect some questions. Yeah.
yeah, exactly, sir, exactly.
Yeah. Please give them 1 or 2 minutes. They will be asking the question. I find that someone is asking a question. Mr.
Hello.
Utpolendu Mondal. Yeah.
I'm calling to
Yes,
speak.
Mr. Mondal. Yeah.
One question is that CPU sensing communication and control, and IoT sensor gateways. What are the future challenges? If we if we
Series.
provide a process in future or at present also, what will be the main challenges can we face?
Sir, I am not able
Drawbacks
to
or
hear you.
challenges we have to face. So, yes, sir.
Sir, I am not able to hear you properly. Can you please
Because of
repeat?
because I am in train, so that's why his network problem is there. Just one thing, sir, what is the challenges regarding these subjects? Face the challenges only.
Challenges for?
Challenges for one is the implementation of CPS and IIoT.
Yeah.
So in the 4 point generations, so we know that each and every work has some have to face some challenges or any problems. Here is challenges means problem. So what types of challenges may come in future?
Okay. So,
Mr. Kumar, if I have understood the question,
yeah,
maybe the challenges can be broken down in 2 parts. One part you have already answered to some extent, possibly covering everything. But if you want to add something, but then I believe his question is also, I mean, what are the challenges in terms of implementing the technologies? I mean,
yeah, got it.
can
Sir.
you can you talk
Yes.
of the readiness? Can you talk of the training needed? Can you talk of the, understanding of the TRL levels, kind of thing? Those are.
Yeah. Understood, sir. Thank you so much for the question, sir. So basically, be it CPS or IIT.
Mr. Mondal, Professor Mondal, I believe this is the question, right? Sir,
Yes, yes.
Utkalendu model? Okay, fine. That's the question. Correct.
Yes.
Yeah.
Got it, sir. Thank you so much for the question, sir. So basically, either it is CPS, which is cyber physical systems, or the industrial IoT. The main challenges that I can find out from my understanding will be the security and the interoperability, which are the real time, which will be the real time challenges that will come. Another thing will be the scalability also, which is something which is of very paramount in this kind of systems. So if I talk about this security and the privacy challenges, so basically the devices generally lack robust security features. And when we talk about layer, which is like edge layer and the gateways, these can
Yes.
be directly exposed to the network level threats, and which might be a reason for a data loss or a data breaches. This is a similar kind of problem that already happened 2 months back in JLR itself, where the data, we got a ransomware in the database, in the main database, and everything has to be shut down. Yeah. Second thing I want to say is on the interoperability, where because the devices are of heterogeneous communication nature. So one device might be using this MQTT or an OPC UA kind of a protocol, while the other uses a CoAP protocol or some other protocol, right? So adoption of an open standard, like that is why I mentioned that a policy is required in this case, so that everything remains in a homogeneous nature. The other thing which I find out, I felt is that the network latency, as we discussed, that the jitters that are going to happen, this can also disrupt the time sensitive information. For example, if there is a problem sensed in an actuator or somewhere in a valve, or maybe there is a thermal propagation in one of the cells in an automobile, and if this information gets gets late because of the latency, owing to the latency of this network, this might harm more than actually benefit. So these are the challenges and the bottlenecks that I feel that are and of course this system is pretty complex, because we don't have engineers, as Professor Dan also mentioned, that like training the people for this kind of problem is also for this kind of system is will be challenging and will be very unique, I would say. So since we have not done this thing before, and it's a kind of a first mover for us, for India, these are the challenges that I feel. Thank you so much.
One thing that question comes that, okay. Oh, yeah. Okay. Acha, well, there may be other questions from
Sure.
participants. Yeah, other questions. Is anybody writing anything in the chat box? Mr. Kumar, can you find any question?
Yeah,
in
I'm
the
just
chat?
checking, sir. I'm just checking.
Please
No,
check if by any chance there is a question in the chat box.
no, sir. Not as of now.
Okay.
Yeah.
Okay.
Yeah.
One more thing that now suppose because there are academicians
Provided
also.
chat box. Hello.
Hello. See, someone is telling something.
Yeah, Professor Utpalendu sir is saying something.
Yeah, Professor Utpalendu Manal, what is this issue?
He's trying to say something, but I feel that there is some disturbance in the back.
No, that is by mistake, because he has
Since he's
muted himself.
traveling.
By any chance it was open. Now my question is that, so now you see, it's a very interesting question, different kind of question. It is I mean, I asked the question from the perspective of an industry professional or expert speaking to academicians. Now I would like to have a view, like, say, if in an academic institution, say for example, one intends to build up a team of CPS capabilities. Okay,
Yes.
because one is not expert of all areas. So
Yes.
how do you advise them? How would you advise? Because see, you are in the thick of things already. You have
Mm.
done some implementation. So, and you know, because you were also in the academic settings for a very long time
Yes.
at IIT Kharagpur, and also in other leading institutes like BIT, etc. So you have seen that other areas. So how, and you have interacted with the very, well-known faculty members. Now,
Yes. Yes.
now, from that perspective, imagine an institute. I'm giving you a problem. Imagine an
Mhm.
institute which
Mhm.
is which is not as big as a premier institute, but
Got it.
it has various departments: mechanical, electrical, electronics and communication, computer science, civil, and also
Yes.
maybe few other departments. Now,
Yes.
those there are motivated young faculty members. Okay,
Okay. Yes.
how these groups or people can initiate, say for example, say for workshop or course on
Yes.
industry
Understood.
4.0,
Yes.
right?
Yes.
Merging their talents, blending their talents, or bringing together the talents or their knowledge is expertise and all. What is your proposal? How to move about it?
So, sir, thank you so much for the question, sir. So basically, what I felt is
I
that
do not know. I ask this question. I believe on behalf of the academicians,
yeah.
because being
No, no,
an
sir. It's a
academician.
very valid question, and during my research on this specific topic, and when I was learning about this topic, I also felt the same way that if we want to implement it as our team, what kind of expertise or what kind of different different levels of people do we require it for it, right? So to answer this in a single line, we need a multidisciplinary structure that can blend control engineering, embedded engineering, software engineering, and specific domains. Like, for example, if you are working on an electric vehicle or if you are working on a battery pack, or it depends on that. So basically, all aligned under a system engineering mindset, I would say, because since it's a full system, end-to-end system. Okay, and
That's it. Yeah, please go ahead. Yeah.
yeah, so like I would say like the core roles that I feel are the most important here are, first will be the model based system engineering, which will be the guy who will be doing the system, which will be called the system architect, which will define the structure, interfaces, and the overall logic, integration logic between the different components, right? And like coming from that, second would be a control engineer, which will do the state space or the real time tuning of these components, designing feedback loops and stability mechanisms. Third would be, I feel, would be an hardware engineer, which will do the PCB design, signal integrity, EMI, EMC, for building physical layers, basically, and ensuring the overall robustness of the system. There must be a safety engineer also, which will like we discussed, that there are some safety protocols which needs to be taken care of. So that's why we require a safety engineer. A simulation engineer will be required for doing the 1D or the 3D modeling, for this, for developing a virtual prototyping and digital twin and post simulations that we require. A network engineer will be required for doing the CAN, the ethernet, or these things, which are the basically the gateways and the protocols and the media, basically, for building the physical layer, and for building the this data, I would say data integrity would be the correct word, I would say. And above all, I will there is one more space which I feel is would be a data engineer or data scientist, which can basically adds intelligence and predictive capabilities to this overall system.
Yeah. Well, wonderful. Absolutely wonderful. Absolutely
So
wonderful.
yeah,
But
thank
but
you so much.
but one might fear that, okay, at least it means say 8 or 10 people are required to
Mhm.
set up one or do that workshop, and so be it, no problem. Because see, in an academic institutions, those many faculty members are available usually
Yes,
with
yes,
with something, or they may pick up something. They may know say up 70% of the thing. Maybe if they add another 30%, then they
Yes.
become a person who can take care of that particular domain or that
Absolutely, sir.
particular aspect of that technology. So now I believe that my question was intended actually that you have answered very nicely, and you have actually put the word that systems engineering. The systems engineering is a concept that anybody for any development one has to understand very thoroughly. I mean,
Yes. Yes.
so can you explain some this systems engineering in terms of, say, for example, thermoelectric systems?
Okay. Can I tell you in a more broader way, in a more advanced?
Yes. As you feel.
So I will take an example.
Still about 10 minutes or more, so you can use that time. No problem.
Yeah. Okay.
Yeah.
Okay. So if I want to talk in terms of a car, like since I'm working in the same area, so
Yeah.
the system engineer basically is somebody who is a kind of who has an understanding the big picture discipline that ensures that all subsystems, which includes the mechanical, electrical, software, safety, and maybe production also, integrating seamlessly into a reliable, cost-effective,
And
and
also there may be the quality and supply chain. This
yes,
also,
of
yeah.
course, yeah, yeah,
So
yeah.
that is
So
exactly
UI and
also,
BI is something which is again important. Yeah.
yeah, because particularly for automotive, the
Mhm.
supply chain becomes a very crucial aspect,
Okay.
because as we know that JIT system, just in time manufacturing, which is part of this automotive industry in
Mhm.
terms of its practice and culture. So supply chain also very important. So can you highlight how is the interface between the software manufacturing vis-a-vis, and also the supply chain aspect, both you know downstream and upstream?
Sir, so can you see my screen right now?
Yeah.
Yeah. So basically, this is called the V model. So
Hmm.
it is so basically it starts with the system requirements and then
Hmm.
going to the system requirements in a very high level and going to basic of each and every component, coming from the system to the basic, and then going and so basically on the left side of this V, you can say the ideation or the design part.
Hmm.
The bottom is will be the implementation, and on the right will be the testing. So this is so this is basically the overall picture of a system engineer. So basically the system
Correct.
engineers sit somewhere in the before the implementation and near this component level. So that person should be aware of integrating integration from a very small sub component to a system level. So
Absolutely.
yeah, so basically here we generally say that in a V cycle we stay in the left bottom side of the V cycle, and these all are like, even if this might not be the exact picture which I am talking about, but in a V model everything is trackable and traceable. So the system engineer ensures that everything is in compliance, coming from a very subcomponent and going up to the level of a final product or a delivery, or even after post sales also. This is something which a system engineer does here.
And here the particular thing, like say in other areas there is a critical thinking, there's creative thinking. Here the particular aspect of system thinking, that
Yes.
that becomes that
So,
becomes
so,
that
so
that that becomes.
in a way, the person, the concerned person or the system engineer should have an understanding from the electrical, from the mechanical, from the thermal, from the software, from the compliance, and from the, as you said, from the quality side.
Right. Now it is a possibly it is the final question from my side, because quite not question, it is a discussion.
Yes.
Possibly here, because listening to this, one would wonder, on the face of it, on the surface of it, how can I have all these capabilities in that mechanical, electrical? I don't have the capabilities of all this engineering. It is impossible.
Mhm.
But but what you are saying, I mean, I think that should be, that needs to be, discussed, is that the capabilities that you are talking of, yes, of course, for the team, and most importantly, where the key role is played by the project manager or the
Mhm.
project in charge, who
Yes.
who and everyone, not only he and all the members, he or she, sorry, he or she or all the team members will
Mhm.
be a T-type professional, T-shaped
Yes.
professional, that the depth will be in one subject or in its domain, maybe electrical, maybe mechanical, maybe software, maybe firmware or something, or possibly quality. I mean, which cannot be
Mhm.
ruled out. I mean, technical quality, of course, because there are some companies who you know that the Toyota Prius was
Yes.
developed under the leadership of a person who actually was from the quality. So having said that, so the T-type professionals, T-shaped professionals who has the breadth, a depth in one domain, but breadth across the implementation or application areas. So, like say a person who has a high capability in say the software, but he understands the its effect and implication on say electronic devices, or say the load or the torque, the mechanical aspect of, or the aerodynamics.
Yes.
Does it make sense? When you understand what I'm saying?
Yes.
That
So, sir,
T-shape.
basically,
Yeah.
like
Yes.
like we have discussed multiple times in your
Correct.
office also, that
Exactly. That is exactly,
that
yes. That is exactly why I am raising these questions,
yeah,
because
yeah.
what we discussed maybe at IIT Kharagpur,
Yes.
or someday, one day, maybe it is useful for young faculty members or other faculty members who are attending this program, because we have discussed so many things earlier, and this is the
Yes.
opportunity, and that is the purpose of this FDP. Honestly speaking, this is the purpose of this FDP, where we are sharing the information, sharing the knowledge. Okay, please. Yeah.
So, sir, as you rightly mentioned that of course, for a single person to be able to understand and have an understanding in each and every domain is a little scarce, I would say. But at
Hmm.
the same time, like myself, like the way I am doing it. So basically, I have an as per my interdisciplinary domain, which says that I have a master's degree in power electronics and working on the PhD side. I was working mainly on the thermal aspects and the fluid domain side. So this kind of an understanding is what is required here as well for a system engineer, because you need not to, there are specific teams divided for the whole work. Let's say, for example, for an electrical team, there is a full-fledged electrical team who is going to go into the depths and understand each and every component from the basics and do the testing and all those things from the component to the system level. But from my understanding as a system engineer, and if even if I don't come from the electrical background, I can say that I should be aware of few things in terms of
Hmm.
testing, in terms of failure, and in terms of working of that component, even though it is not very in depth. But at the same time, since I will be the person who will be responsible for the integration it with another subcomponent, which might be a mechanical component as well. For example, in transmission might be a mechanical is compared to the and before that we have this shaft which is connected to a motor is an electrical component. So from a system engineering perspective, it should be more of an integration centric, and a overall a bird eye view or a high level understanding would be sufficient for this thing.
Great. Wonderful. Absolutely wonderful. Great. I believe your interaction has been superb. I mean, there are various domains and dimensions that has come very clear and lucid, because technology is one aspect, and how the technology is to be managed is another aspect, which is very pertinent and important for Industry 4.0. Because Industry 4.0, if you can think of, was first proposed, though it is a government project in 2011, but it was proposed in the World Economic Forum in 2015. So you can understand that it is such a global thing. It is not possible to be managed by a single individual, but as a team. and the team capability we have discussed. So great. I mean, it is a very fascinating discussion. It was a fascinating discussion.
Thank you so much, sir.
Yeah, and
Sir, I can see there are a few questions here in the chat
okay,
box now.
okay. So I will not hold you back. From
Yeah.
my side, I sign off.
With
Sign
your
off, and
permission,
I'll be here. But
can we
take
just
this.
address
Yeah.
it one by one?
Yeah.
And I'll try to quickly
But
finish
you
it.
have only 5 minutes left. So, Mr.
Yes,
Kumar,
yes. Okay. I'll try to quickly finish
sure.
it.
Of course, by all means.
So the question from Abhishek Majumdar says that what is the role of a blockchain in the CPS? So although we have not discussed it much, but if I want to tell you on the contribution of a blockchain, it can provide a decentralized trust and a secure data exchange and a tamper resistant record, which is very much required for making a CPS more resilient against the cyber attacks and ensuring reliable coordination between the physical and the digital components. So basically, if I want to give you a line like answer in a single line, it would be data integration and tamper resistance is something which I feel is can be very helpful for developing a blockchain technology in the CPS as well. Okay. Coming to the next question, which is how, okay, Dr. Ritam Shira, that how cost of development can be amortized. So I'm assuming this is for the CPS, right? So basically, it's a very good question that in CPS the development costs are very high because you are integrating hardware, software, networking, and safety critical elements. So basically, amortizing, or I would say rather spreading out these costs is essential to make a project financially viable, and that too across their whole life cycle. So coming to the life cycle cost amortization, I can say that it can be from the concept and the design phase, one thing, and the other thing will be the prototyping and testing phase, and third will be the deployment and the maintenance, if at all, if you are thinking about the maintenance side also. So life cycle cost amortization, if we can do, this is the first thing and the first steps for developing a CPS from the scratch. Yeah, okay. I think I am done with the questions.
Yeah. Ashish Kumar.
Yeah.
So
Yes.
it's a wonderful session. Now we are at the end of the session. So thank you very much. Now I request all the participants to join our next session. We'll be starting from 7:30. So thank you very much. Thank you, Ashish Kumar.
Thank you, sir.
Thank you.
Yeah.
All the participants, before leaving the session, please fill up the feedback form that I have shared in the chat box. This is very much necessary. Please fill up the feedback link that I have shared in the chat box.
Deep, I can leave, right?
Yes, sir. Certainly. Thank
Yeah,
you very
thank you
much,
so
sir.
much. Thank you, sir. Thank you.
Only 37 responses are there, 39 currently. Please fill up the feedback link that I have shared in the chat box. Okay, thank you very much, everyone.